Assalamualaikum and hello everyone. My name is Nur Shaira Bandi Zunaidi. My ID number is MA190X7. I'm from BMM3521, which is Engineering Fluid Mechanic Labs. And I and my fellow friend will present about the lab report 1, which is Bernoulli principle. Let me start first for abstract. This report is about Bernoulli principle experiment. This experiment will investigate and calculate the variation of total pressure head, static head, and dynamic head as we learned the Bernoulli equation in previous semester. The materials we use in this experiment are hydraulic bench and Bernoulli principle demonstrator. The multi-tube is for the static head measurement, the venturi apparatus for static head and dynamic head, and the pitot tube for measuring total pressure. We must also collect all data and attempt to apply it to the Bernoulli equation.
The Bernoulli principle has been invented by Daniel Bernoulli, who is a Swiss mathematician. It is first derived in 1738 and been published in his own book, which is Hydrodynamics. However, Leonhard Euler, who is also a mathematician, had derived the Bernoulli equation in usual form in 1975. The main idea of the principle in fluid dynamics is if the speed of fluid increase, the decrease in pressure and potential energy will occur simultaneously. This principle only applied for isentropic flows where the irreversible and non-adiabatic process can be neglected. Here is the Bernoulli equation, and the equation can be derived from principle of conservation of energy or directly from Isaac Newton's second law of motion. The problem statement in this experiment is we are in need of to determine the variation of total pressure, static and dynamic head in this experiment. The pitot tube used to measure the total pressure by the right side of the apparatus measurement reading. Beside, multi-tube manometer at the top of apparatus is being used to measure the static head. The static head and dynamic head can be varied using venturi apparatus. Within the venturi, the static and total head will be measured at 6 points at any flow rates, and the flow rates is then measured by volumetric tank. From dynamic head and through volumetric tank, the 6 point of fluid velocity within the venturi can be calculated. The objective of this experiment is the Bernoulli's principle can be explained for an incompressible liquid. The concept of conservation energy of a liquid in motion can be understood and become more familiar with correct methods in calculation, evaluation, and measurement. The scope of this experiment is carried out in order to verify the validity of Bernoulli's principle. At the end of this experiment, incompressible liquid in the principle can be explained and concept of conservation energy of a liquid in motion can be understood. The total pressure, head, static head, and dynamic head can be determined in this experiment. The task was distributed evenly among the group members to produce a report regarding this Bernoulli principle experiment. The report will be represent students' understanding of the experiment, safety and knowledge of the Bernoulli equation and principle implied.
Assalamualaikum and hi, I am MA1983, one of Nabila. We continue to explain about the theory and also experimental procedure. For the theory, Bernoulli can be explained as a steady and frictionless flow that can be seen from the law of conservation energy, mass and energy. From this, we could conclude that mass input in a control volume equal to mass output in a control volume given in the equation. The basic of Bernoulli theorem is from the combination of two laws, which is the work and pressure, and combined together to make an equation for Bernoulli theorem. Since the experiment will conduct in a horizontal duct, thus the height difference can be discarded. So as you can see, there is a difference between the original at the left side equation and also the right side equation, which is were modified after we doing the experiment. For the procedure, we have 19 steps in the experimental procedure that we're doing carefully during the experimental. The first thing that we need to remember is to avoid doing a thing that can make accident happen. For example, we should make sure that the table is clean without water spilled around the table, and also all the hose and electrical supply were fully connected in a good condition, which is if something happened, we should actually call our supervisor to check either it was safe for us to use or not. So this is all the steps that we use during the experiment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Shakira binti Muhammad, MA1912. So for experiment 1, we have done Bernoulli's principal experiment. From the calculation, we got the result for experiment 1, which is dynamic head, measured velocity, calculated velocity, dynamic pressure, and head total. To calculate the dynamic head, hash p dot minus hashtag 4.1. To get the result for hash dynamic, hash p dot, we substitute with 185 and minus hashtag, which is 180. So we get the answer 5 millimeter. For measured velocity, we use the equation velocity measured equal to volume flow rate over area. 4.1. We got the answer for velocity measured is 0.5590 n over s. We substitute volume flow rate, which is 2.2727 times 10 exponent negative 4, and area is 0.33 times 10 exponent negative 4. For dynamic pressure, we use equation ρgh 4.1. We substitute ρ equal to 1000, G is 9.81, and H dynamic 5 times 10 exponent negative 3, and we get the answer for 49.05 Pascal. For total heat, we use the formula hashtag plus velocity measured over 2G. We substitute hashtag, which is 180 times 10 to the power of 3, plus we measured 0.2590 over 2G, which is 2 times 5.81, and we get the answer 186.05 millimeter. The result 4.2 and 6 is using same calculation. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Karinisa binti Azmi. My ID number is MA19102. Now I'm going to present about graph. Okay. For the first graph, we are plotting for the head static and also head pitot versus point. The orange one is the graph for the head pitot, and the blue is for graph head static. Okay, the data that we upload, we got from the part of calculation that have been shown before. The next second graph, there are measured velocity and calculated velocity against the position in the ventimeter. The blue one we can see here, this is for measured velocity, and the orange is for the calculated velocity. So we can, from the graph, we can see that the pattern of the graph is different. Last graph is total head against the position in the ventimeter. Okay, for the discussion from the graph, you can see the calculation and graph above. The interior diameter and area of the ventimeter will affect the increasing and decreasing data for the static head and pitot head. The value of the static head decreases when the diameter is small and will be increased when the diameter is bigger. This happens because the fluid velocity will be increased as the area decreases at a constant flow rate. From the graph, we also can conclude that the pattern of static head and pitot head versus point graph curves is quite similar. This is because the total head is equal to the pitot head, but there is a big difference at the point 3 where the graph of the pitot head is slightly going down compared to the total head that occurs because of the head loss in the ventimeters. Okay, from the graph 4.2, we can see that the pattern measured at velocity graph and the expected velocity is very different. Graph of measured velocity is increasing at the first and third point with very high value of increasing and decreasing at the fourth point until point 6. Why the calculated velocity also
Lastly, I will
increase and
cover
decrease
fourth
but
part
just a
conclusion.
small value.
In conclusion,
That's all
according to
from me.
Bernoulli, a high velocity of the fluid flow results in a low pressure, and a smaller area results in a high velocity. Consequently, both proven correct equation might be used to figure out how a fast fluid moves a millimeter. Even if the value is not precisely the same, there is a pattern of growing, decreasing at the converging and deconverging edge. The deconverging part is the same. As a result, as the velocity rises, both convergent and deconvergent flow. There is 3 tips and 3 questions to follow during experiment to acquire correct data. Firstly, the equipment must be drained before and after the experiment to avoid harm to the experiment. Secondly, truly comprehend the unit and method to prevent making an easy error and experiments should not be carried out. Lastly, the suction pipe must be start concurrently with the timer to get an exact volumetric flow rate. That's all from us. Thank you.